All right, so it's that time again. So like I said yesterday, the chapter 9 is done. So now what we're going to do is we're going to go ahead and start chapter 3. We'll do 3-1 today, 3-2 tomorrow probably, and at least start 3-2. 3-2 is longer than 3-1. And then we'll take the test on Thursday. So that's kind of how we are right now. So any questions before we get going?
Hey, quick question. So, is the test going to be more like how the My Open Math homework is, or is it going to be more like the stuff we did in class?
It's more like the stuff we did in class. So basically, I'm going to take examples out of the book like I usually do. And what I've done is I just took the test that's a paper-based test, copied it into Moodle. So it's the same problem as if I would have the paper-based, but then you just have to type the answer in Moodle. And then I think once you're done with the exam, all the papers that you've written on or whatever to show your work, if you could then take a picture of those and email them to me, that way I can see where you went wrong if there's a place you went wrong, why your answer is wrong anyway. So I think that's what we're going to try for this first test. If it works well, then we might do that for the rest of them as well. We'll kind of see how it goes from there, though.
Cool. Thank you.
All right, let's go ahead and get started. So again, we're starting chapter 3, which is on polynomial and rational functions. And this first one's on complex numbers. So we're going to start with some imaginary numbers finally. And so what is the square root of -1? Well, all the times before probably you've been told in different classes it's I, and that's what it is. And let's see, probably starting in 930, that's probably the first time you've seen I. 920 and below, we just say you can't take the square root of a negative number. So now we're saying you can, and we're calling it imaginary number I. Now, if we square I, then we're going to have basically the square root of -1 squared. And so the square root drops off, and that's equal to a -1. So by definition, these are two kind of important things that you'll need to remember. When we get to the very end, we'll start with going from I to the first all the way to I to the 8th. And then what we're going to do is we're going to work on things that are like I to the 25th or something. And what does that equal to? And so there's going to be a thing we're going to look at and see how we can work our way down to getting simplified terms. And so that's going to be something we'll see here at the end. But what is a complex number? Well, a complex number is basically a sum of a real number and an imaginary number. So it has two parts. So in standard form, we have a plus bi is our complex number. And the a part here, that's the real part of the number. So that's like 1, 2, 3, 4, whatever. And then we have this part, the bi, that's the imaginary part. And b is just going to be a normal number. And I makes it the imaginary part of the number. And if we have a equals 0 here, like it says, we just have strictly an imaginary number. We don't have the real part, so it's not complex at that point. And so then it's not a complex number. Some people have the statement that if you have, say, 0 plus 2i, that's still a complex number, even though a is equal to 0. I'm up in the air if it's in this form, it's a standard form and it's a complex number, but then you have, a is equal to 0. So it all depends on how you want to define that part of the real number or not, because 0 is a real number. So technically this is a complex number. So if we have a number like 5 plus 2i, that's a complex number. And the 5 part here, that's our real part. And the 2 is the imaginary part. Now it's 2i, but 2 is really the part that we're really looking at, because what we're going to eventually do is we're going to add and subtract complex numbers. And so we're going to really just add the part here, the 5 plus whatever other complex number we have. And when we add the 2i to some other part of an I, we're only going to look at that 2 part. We're not going to add I plus I, because whatever it is we're going to have that number in front of the I, which we're going to do the work on. And so that's the two pieces. 5 is the real part and 2 is the imaginary part. Now, sometimes they'll want you to express some square root of a negative number in standard form. And so what you have to do is you have to kind of break the square root down. And so first off, we know that the square root of a negative 24 is really just a square root of negative 1 times square root of 24. And the square root of negative 1, we already said is I. And so that's the easy part. Then the square root of 24, we just break down into, well, 24 is 4 times 6, and the square root of 4 is 2. So we're going to have 2 times the square root of 6 times I. Now, if we want it in complex form, which is the standard form, this is why I say some people say it's not a complex part, but some say it is. Here we would have 0 plus our 2I square root of 6. So I'm going to bring out that I up here and put it out front. So I'll have that, because some people, when you're typing or writing, what happens is it looks like you have that when you really have the i's outside of the square root, and so you have to really be careful with that. And so if you don't do that, instead you do the I square root of 6, that'll be sure to have it so it's in the correct format, because when you're typing on the computer, sometimes if you don't hit a space after your 6, or you don't hit an arrow to the right, then it keeps that square root going over it, and so then it shows it's the square root of 6i, which is something different than I times the square root of 6. Okay, we can also graph complex numbers. So what we have to do is we have to have a different coordinate system. And so the horizontal is going to be the real part. That's going to be our initial part. So our, in this case, the 0, that's going to be the real part. So that's the horizontal. And the vertical, that's going to be our imaginary axis. So whatever our imaginary number is, we'll go either positive to the top or down to below. And so if we plot this point and say this is our point, what does that equal to? Well, on a real part, it's 1, 2, 3 over. And on the imaginary part, it's 1, 2, 3 down. So that's going to be a positive 3 for the real part and a minus 3 for the imaginary part. And then we'd put I on the end there. And so what I'm going to do now is I'm going to take and just do a couple examples. I'm going to have to draw my graph, and then I'm just going to plot both of those pieces. And so I'm going to plot them both on the same graph, so I don't have to draw two graphs. And so again, your real part, you're going to go so many to the left and so many to right, however far you want to go. And same with the imaginary part, you're going to go up and down, however many it is. So if we want to plot this first, the real part says we're going to go left 4. So we're going to go 1, 2, 3, 4. And then the imaginary part says it's negative 2. So we're going to go down 1, 2. And so that would be our point, the negative 4, negative 2i. So if we call that, that's going to be our point 1. Now this one, which says we're going to go right 5 because it's going to be positive. So we're going to go to the right 5. So 1, 2, 3, 4, 5. And then it's a positive 4, so we're going to go up 4. So up 4, right 5, that puts us somewhere about there. 1, 2, 3, 4, 5. Yeah, so that looks good. And so that's our point 2. So our last one, we showed 3, negative 3 was here. That was 3 minus 3i. And so maybe if we plotted this point here, that would be 1, 2, 3 left. So it's going to be a negative 3, and it's going to be plus 1i, or you could just say plus I. So you can plot points, or if they give you a point, you can kind of write out what it is. And again, the real axis is the horizontal, up and down is the imaginary. All right, so this gets to the point where we're going to add and subtract complex numbers. So adding and subtracting, really what we're going to look at is real parts and imaginary parts and imaginary parts. So if we have the a plus bi, and we're going to add to that c plus di, the real parts are the a and the c. So we're going to put those together, and we'll add that and say, what is a plus c? Then we're going to look at the imaginary parts. So this is kind of like the number, and this is like the one with a variable on it. And so we're going to kind of look at the I kind of as our variable to kind of keep it in line with each other. So then we'll have B plus D times our I. And so that's going to be our imaginary part. And subtraction works basically the same way, except you're going to subtract. You're going to take A minus C, and you're going to take B minus D, and then times your I. Okay. So if we do that with actual numbers instead of just letters, what we have here is we have a minus 2 plus a 1. So if we write it kind of like we have up here, we have a minus 2 plus 1 plus, and then we have a minus 4 plus 6 times I. So minus 2 plus 1 is minus 1 plus, then we have 6 minus 4 is 2 times I, and that then would be adding those two complex numbers together. Now here we're going to subtract, so we're going to have 2 minus, and here we have a 3, then plus, now here we have a negative 3, then we have minus 2 times I. So we have 2 minus 3, so that's a minus 1. Here we have minus 3 minus 2, that's a minus 5, so we'll just say minus 5 times I. And so then those two complex numbers subtracted give us a minus 1 minus 5I. Okay. And so really this isn't going to be anything different than what we've seen with, if we just had something like 2 plus x and plus 3 plus 4x. What we did was we took the like terms and added them. So 2 plus 3 was 5, x plus 4x is 5x, and it works the same way, except now we deal with that imaginary number instead of the variable x.
Isn't that one minus?
Which one?
Number 2.
2. Minus 3 minus 2 is going to be minus 5.
Wait, but like the plus sign that's in between, like with the first line that you wrote on the, nope, the bottom one.
This
Oh,
one?
you add them even though they're minus?
Well, what happens is you really, it's kind of what you do is it'd be kind of like this one. Say we had 2 plus x minus 4 plus 3x or something. What you do is you look at these pieces. So you're going to say that's 2 minus 4, and then still plus, and now you have 1x plus 3x, so that's x plus, well, I guess we need to put our numbers to make it so it's similar. And so then we had our variable numbers as 1 plus 3, or 1 minus 3 rather. Here I'm talking faster than I'm writing, or writing faster than I'm talking. So now we have 1 minus 3 times x, and so 2 minus 4 is a minus 2, and minus 3 plus 1 is going to be minus 2x. And so even though you say you're subtracting here, what you do is you add them, but the subtraction goes on inside of your parentheses. And that's kind of what we're doing here. Even though it says we're subtracting, we say it's add, and we do the subtracting within here. Does that make sense?
Yeah, that makes sense. Thank you.
Mm-hmm. All right, so that's adding and subtracting. So multiplying is going to be pretty similar. Now what we're going to have to do is we're going to have to remember that I squared is going to be a negative 1 if we ever run into that. And so that's going to be a key thing to remember. So you always want to simplify these as much as possible. All right, so if we have something simple like some real number and a complex number multiplied together, that's going to be like this first example here, where we have the minus 4 and then the 2 plus the 6i. All right, then the second one is multiplying two complex numbers. And basically what we're going to do is just FOIL and simplify. So we're going to just have to do the FOIL process all along. So the first one is just going to be just distribute. We're just going to take that times that and that times that. So minus 4 times 2 is minus 8. A minus 4 times a 6 is a minus 24, and it still has an I. So we can kind of think of that I as a variable, and as long as we just have I, we are done with that. Now this one is going to give us that I squared, and so we're going to have to do some work and a little bit more besides just multiplying it out. So here we're going to take first times first, so 3 times 2, so that's going to be 6. Then we'll take the outer, so we'll take 3 times the 3i, so that's going to be plus 9i. Then we'll take our inner and multiply them, minus 4 times 2, so it's going to be minus 8i. And then a minus 4 times the 3i, so it's going to be minus 12i squared. Okay, so when you multiply I times I, it's just like x times x, it becomes I squared. Now we can simplify, so that becomes 6 and then plus I and then minus 12. Now remember, I squared is a minus 1, and so that's really a minus 1 there. So we're going to replace the I squared. If If we ever have any number or letter I to some power, we want to reduce it to as much as possible. So we always wanted to get it down to just an I. And then in this case, I squared is just -1. So we just actually replace it with a -1. Now we have to multiply here, so that's going to be 6 plus I plus 12. So now we add those two together and we get 18 plus I in the standard form. Okay. And so then at that point we're done. We can't, I is just I, we can't change anything there. And we have, the A plus BI, where B in this case is our 1. All right. And you can do this, if we have even more complex numbers, if we have more than 2 times 2, if we have a 2 times 3 or higher, you just have to kind of keep doing the rainbow until you, get all of them done in your multiplication. All right, now the complex conjugate is going to come into play because what we need to do is we're going to want to simplify fractions. And to get rid of fractions, we always want to get rid of the denominator with an I value. So the key is to find the complex conjugate, and then what we're going to do when we get to fractions is we're going to multiply by the conjugate on the numerator and the denominator. So to find the conjugate, what we do is if we have our first one, say it's A plus BI, the conjugate basically is we change the sign on the imaginary part. So if we had a plus here, then it becomes A minus BI. Now if we had, say, A minus BI was our original number, the conjugate is the opposite here. So that's going to be A plus BI. So depending on if you start with plus, your conjugate is going to be minus. But if you start with a minus, your conjugate is going to be a plus. So if we find the complex conjugates here, we just look at that sign there and we just change it to the opposite. So that's going to become 3 plus I square root of 7. And this one, well, this one is going to be, the conjugate is going to be 2/3 I. Now here we could argue and say, well, if we're going to find the complex conjugate, we really need to have that, real part. So it's going to be 0 plus 2/3 I. And so even though they didn't give it to us as a complex number here, we turned it into the complex number here and put that 0. And so that way we know for sure what the complex conjugate is. Okay. And now this works with, any numbers we want to try or any variables. Maybe we had instead -4 minus 5I, and maybe let's also say we had a 7 plus 10I. So it doesn't matter what our values are. All we do is we take the opposite of whatever it is. So the conjugate is going to be a -4 plus 5I. And here, the opposite of that's a negative, so it's going to be 7 minus 10I. And so that would be our conjugate here. And so again, these are going to come into play when we actually start dividing complex numbers, which is going to be what we do next. And to write complex numbers as division, what we need to do is we need to write it as a fraction. That way we can see the original number here, and then we can figure out what the conjugate is. And so what the second step is determine the complex conjugate of the denominator. So in this one, if that's our original number, the conjugate is going to be, it looks like a G, but whatever. Here, let's erase that. The conjugate is going to be a -2I. Okay, so again, that's a plus, so the opposite is a negative. And then what we do is we multiply the numerator and denominator by the complex conjugate. Because if you multiply by numerator and denominator, basically you're multiplying by 1. And what eventually is going to happen is we're going to try to get rid of, again, like I said, all the i's in the denominator. We don't want that. So if we multiply by a -2I over a -2I, remember that's just 1. And so we haven't really changed the number. We're just changing kind of what the overall numbers are going to look like, but it's the same fraction answer. And so when we multiply here, what we get, well, if we multiply on the top, we'll take -2I times the -5, so that's going to be a positive 10I. 3I times the -2I is going to be -6I squared. And 2 times -2 is going to be a -4I squared. Okay. Now at this point, again, we don't want the I squareds or any term value larger than 1 in the exponent. And so I squared is equal to a negative 1. So this is 10I minus 6 times negative 1 over a minus 4 times a negative 1. So here that is equal to minus 6 times a minus 1. So it's 6. If we write this in standard form, then the I will come next, plus 10I all over minus 4 times a minus 1 is a positive 4. Okay. Now, but that really is not where we stop. What we want to do is we want to simplify this into, again, standard form. And so we're going to take 6 over 4 plus 10I over 4, because then we'll have kind of like our A plus our BI. And now we need to reduce. So 6 over 4 is the same thing as 3 over 2 plus, now this is going to give us a 5 over 2 or 5I over 2. And now we have in the original form that we need it in, which is the standard form, and we've gotten rid of our I in the denominator. We only have I in the numerator right here. And so therefore that has now been simplified, where we've split the real and imaginary parts in step 4. Okay, and again, the key thing is finding your conjugate first, which is in this case the negative 2I, multiply numerator and denominator by it, and so we use our multiplication rules. And then after that, we simplify by getting rid of our I squared by changing it to a negative 1, and then just keep reducing down until we have our A plus BI form and reduced any fractions if there are any fractions that need to be reduced. So let's look at another example. So here we have actually complex number divided by a complex number. And so the conjugate here is 4 minus 3i. And so we'll multiply both the numerator and the denominator by that. So we'll FOIL. So 2 times 4, that's going to give us 8. Then outer, 2 times the negative 3i is going to be a minus 6i. And then the inner is going to be minus 3 times 4, so that's going to be a minus 12i. And then last, minus 3 times a minus 3 is going to be plus 9, and then I times I is I squared. And same thing on the denominator. Well, 4 times 4, that's going to give us 16. Then we'll have 4 times negative 3i, so it's going to be a negative 12i. And then 3i times 4i, so it's going to be plus 12i. And 3i times a minus 3i is going to be a minus 9i squared. Now, because these are conjugates, we would expect this to happen, and our middle terms do cancel, and that's what they should do. And so now simplifying even more, we have 8. Then we have minus 6 minus 12 is going to be minus 18i. And then I squared is a negative 1, so we're going to have plus 9 times negative 1. And that's all over 16 minus 9 times negative 1. And so here that's going to give us 8, and then that's going to be a minus 9 minus 18i all over. Here we have 16 plus 9. And so 8 minus 9 is going to be a minus 1 minus 18i all over 16 plus 9 is going to give us 25. Now we need to simplify this into the form, again, A plus BI, so we need to get rid of the fractions over 1. So this becomes a minus 1 over 25, and then minus 18i over 25. And then at this point, then we have our A, we have our B, and then we have our I. And so this is our final form. And so that is this complex number divided by this complex number into the final complex number form. Okay, any questions on that? All right, so the next thing we have is basically evaluating complex numbers. And so we have a function, and then they want us to evaluate a function at some complex number. Sometimes it's just an imaginary number, sometimes it's a complex number. And so what we do is we're just going to plug in whatever our complex number is, or imaginary number, if it's just 0, minus, or plus I, and we plug that in place of our x's. So nothing more than what we've done before with just normal numbers. So f of 8 minus I is equal to 2 times 8 minus I, the quantity squared, minus 3 times 8 minus I. Okay. So now what do we do? Well, now what we have to do is we have to basically square this, multiply this, and then go through and simplify until we get to our final complex number. So if we need to, let's go ahead and write this out to the side maybe. And so maybe we have 8 minus I times 8 minus I. And so that's going to be 8 times 8 is going to be 64. And then 8 times a minus I is going to be minus 8I. And then we have another minus 8I. And then we have a minus times a minus is going to be plus. And that's going to be I squared. So that's 64 minus 16I. And then this is changing over to minus 1 because I squared is negative 1, and 64 minus 1 is 63 minus 16I. So that's the part here. Now we just have to take that times the 2. So now we'll take 2 times 63 minus 16I. So if we take that, that's going to be 126, and then that's minus 32I. And so that is what this first piece is. So if we write that 126 minus 32I, there we have that. Now we have to multiply here. So that's going to be minus 3 times 8. So that's going to be minus 24. And then we have minus 3 times the minus I. So it's going to be plus 3I. So if we simplify that, that's going to give us 102 when we take that minus that. And then we have a minus 32 plus 3, so that's going to give us minus 29I. And so now we have our final complex number, the a, and then plus the bi, where a is 102 and b is a negative 29. And we have then evaluated that function at that complex number. Okay. And again, a lot of this is just plugging in values like we've been doing. And the only difference here is once we get that I squared, if we have an I squared over here like this, or if we have something that we can simplify, we have to reduce it down. And so then we only have that, just a simple I. We don't have the I squared, and we have our A over here. Okay. So let's do one now where we have a complex fraction over a complex fraction, and we're going to add in our value of I here, negative I rather. So what do we have? We have f of negative I equals, now we have a negative I plus 1 divided by negative I minus 4. All right, now remember, it's the I part that is making the conjugate here. It's not the 4 part. So if we need to rewrite it as 1 minus I over a minus 4 minus I, so we don't forget that this is where we need to take the conjugate of, we can. Or if we know that, the conjugate really is of that first term, we can go ahead and just say, okay, the conjugate is I minus 4, multiply numerator and denominator by that and continue on, then we're fine. But if we need to, we can write it in standard form. And so then when we multiply, we're going to multiply by a minus 4 plus I and a minus 4 plus I. And now we just have to do the math. So FOILing in the numerator, 1 times a minus 4 is minus 4. 1 times I is I. A minus I times a minus 4 is going to be a plus 4I. And then minus I times I is going to be a minus I squared. That's all over. Now we have a minus 4 times a minus 4, so that's 16. And then remember, when you multiply that, that's going to be a plus, that's going to be a minus, so our middle term drops out. So all we have left is a minus I squared. Okay. Now we can go ahead and make the I squared is equal to negative 1, add anything else together we need to. So that's going to be minus 4 plus 5I. And then a minus 1 is going to be plus 1. And here we have 16 minus a minus 1, so it's going to be plus 1. So minus 4 plus 1 is going to be a minus 3 plus 5I, all over 17. Okay. Now we just need to get that into the regular format for a plus bi. So that will equal minus 3 over 17 plus 5I over 17. And then that would be our complex number in standard form, evaluating this function at f of negative I. Okay. So again, nothing really hard. The key with the fractions, we always want to get rid of the I in the denominator, so we need to multiply by the conjugate. And when we do that, all the i's disappear because it usually ends up having an I squared. Then that becomes -1, and so then it simplifies down to a nice a plus bi. All right. So the next thing is kind of looking at those powers where you need to simplify. So, we could go from I to the first all the way to I to the 1/1,000,000th or whatever. And really it follows the pattern. And so what I've tried to do is kind of type out the pattern here. So I to the first, well, that's just I. Then we know I squared is -1 kind of by definition. And then if we go to the next one, I to the third, well, that's just I squared times I. And we know I squared is -1 based on that. And so -1 times I, well, that's just negative I. And so that's how we're going to keep going down, all the way down. We're going to take, now I to the fourth, we're going to take I to the third and times I, because when you take 3 plus 1, that's 4. Well, I to the third we found was a negative I, so it's a negative I times an I, which gives us a negative I squared. And so minus a -1, that's just equal to 1. Now this repeats because now once we get to this stage, we're going to make and multiply I to the fourth times I, which is I to the fifth. And if you write that like this, like the I to the fourth times I, well then I to the fourth we just found was 1 times I is I. And so as you can see, multiples of 4 basically are going to be the same. So I to the first, 4 more, and that's 5. You get back to I squared, go back, add 4 more, is I to the sixth, and we get -1 here as well. And we can just keep working our way down like that and just, continue on through the whole thing and figure out our answers. So really all we need to have is those first 4 figured out, and then we can figure out anything after that. But, if we have the first 8 or the first 16 or however many figured out, that's fine as well. But those first 4 are really the ones that are going to repeat. And so as long as we know, these 4, we can figure out anything else from there. All right, so if we do it and we base it on just the first 4, I to the 15th is going to be I to the fourth times I to the fourth. So that gives us 8 times I to the fourth. So that gives us 12. And if we do one more I to the fourth, that's going to be too big. And so we have to take I to the third. Okay. Well, we know I to the fourth is equal to 1, so that's going to equal 1 times 1 times 1. And we knew I to the third was a negative I, and so we just get I to the 15th is equal to our negative I. Okay. Now, if we had gone instead and said, well, we know I to the 8th is 1, we could have taken, well, I to the 8th, and then we're like, well, we can't do another I to the 8th because that's I to the 16th. So then we have to take I to the 4th. So then we have our 12. Then we could do our I to the 3rd. And so that's 1 times I to the 3rd, which is a negative I. And we still get our same answer. It just used different exponents here. So, the simplest ones is just doing 1 through 4 and kind of coming up with those and then working our way down. Or if you know higher ones, you can use those. But, again, I say just learn those 4 and you don't have to worry about anything else from now on. All right, so I to the 25th. Well, that's going to be I to the 4th times I to the 4th times I to the 4th times I to the 4th. So we have 16 times I to the 4th. That's going to be 20 times I to the 4th. That's going to be 24 times I. Okay, because that'll be 25. Well, each one of those is 1. And so then it's just 1 times basically I. And so our answer is just I. So again, you can do any value for our n, if we take I to the n, we can simplify it using just the 4, 3, 2, and 1. So depending on what we have, we just have to do combinations to get to the point we need. Are there any questions on that? Just the simple ones here where we just simplify I to some value and get it down to an I to some power of 1 or a negative of it, or just an actual number 1 or negative 1. All right, so let's do one then where we're going to take and we have values in the denominator. And so what we want to do first is, before we go and start multiplying by conjugates, we have to figure out what we have. And so what I'm going to do is I'm going to say I to the 11th equals and I to the 21st equals. Well, that's going to be I to the 4th times I to the 4th, that's 8, times I to the 3rd. And so I to the 3rd is negative I. And so that just gives me 1 times a negative I. Okay. Now I to the 21, I can say, okay, well, that's I to the 4th times 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 I to the 4th. 1, 2, 3, 4, 5. That gives me I to the 20th times I. Well, each one of those I to the 4th again is 1 times I, so that's going to just give me I. So what I've done is I've said, okay, well, this is 1 over a negative I, and then minus, and then we just have 1 over I. Now, remember, this negative in the denominator really could be anywhere. What we could have is we could have a negative 1 over I minus 1 over I. So now we have the common denominator. So minus 1 is going to give us negative 2 over I. Now, again, we don't want the final answer of a problem to have I in it, and so we have to multiply by the conjugate. Well, if this is I, the conjugate's going to be a negative I, so I have to multiply negative I over negative I. So when we do that, we have a negative 2 times a negative I, so it's going to be a positive 2I. Here we have I times a negative I, so it's going to be a negative I squared. Now remember, I squared is negative 1, so it's going to be 2I over negative 1. Well, that's just equal to 1, so this just is equal to 2I. So this subtraction of two numbers that are, well, they could be complex numbers, but they're imaginary numbers, ends up being just 2I. Now, if we wanted it in the standard form as a complex number, that would then be 0 plus 2I. So if we want it into the complex form, we'd do that, but it's really just an imaginary number, and it's going to equal 2I. So any questions on that one before we move on? All right, let's do one where we have to divide. So in this one, what I'm going to do first is I'm going to FOIL the numerator, and then from there we can multiply by the conjugate of the denominator. So if I FOIL the numerator, that's going to be 1 times 2 is 2, and then 1 times the negative 4i is a negative 4i, then 3i times 2 is going to be plus 6i, and 3i times a minus 4i is going to be minus 12i squared. And again, that's all over 1 plus 2i. Now simplifying, this goes to negative 1, and so we have 2 plus 2i when we add those two together. And then minus 12 times a minus 1, all over 1 plus 2i. So minus 12 times minus 1 is positive 12. So 12 plus 2, so it's going to give us 14 plus 2i over 1 plus 2i. All right. Now we need to multiply by the conjugate. So if we bring this all down here so we have more room, 14 plus 2i over 1 plus 2i. The conjugate is going to be 1 minus 2i. So we're going to multiply numerator and denominator by 1 minus 2i. So with FOIL again in the numerator, so 14 times 1, 14. 14 times a minus 2i is going to be a minus 28i. 2i times 1 is going to be plus 2i. And 2i times a negative 2i is going to be minus 4i squared all over. Now when we multiply by the conjugates, this can be square of the first one, which is 1, and then it's going to be minus 4i squared because all the middle terms drop out. That's going to be plus 2i, that's going to be a minus 2i. And so now what we can do is we can add those two together and we can convert that to a negative 1. So 14, and then it looks like minus, and then that's going to be 26i minus 4 times minus 1 all over 1 minus 4 times minus 1. So here minus 4 times minus 1 is plus 4 plus 14. So it's going to be 18 minus 26i over 1 plus 4 is going to be 5. Now we want it in the form the a plus bi. And so if we do that, that's going to be 18 over 5 minus 26i over 5. Okay, and so that gives us our a is 18/5 and our b is minus 26/5. All right, so any questions on that one? All right, so that actually finishes 3.1. So I don't know, do we want to start 3.2 or should we go ahead and just let you go so you can work on 3.1 homework and also continue studying for the test?
Are we gonna do a review at any point for like anything that's on the test on Thursday, or is that should we just do the one that's on Moodle or My Open Math or whatever?
Yeah, just do. We're probably not going to do that in class because with that extra week off, we got put behind, and so we're going to be cutting it close to finish because we're sort of required to still get everything done, and so we'll cut it close on as far as getting the material covered as it is. So I don't think we'll have any reviews, but yeah, just do the problems in the book, and if as long as you can do those, you'll be fine. Now the key one, I've already made the test up. Um, there's going to be basically 3 questions out of each section, except for the last section. There's going to be 4, so there's going to be one of each kind of partial fraction. So like in section 1, there's going to be 2 systems of system of equations, 2 variables, 2 unknowns, and one of them might have fractions, one might have decimals, one might have whole numbers or something like that. But there's going to be 2 just systems given to you, and then there's going to be one that's an application problem of a system. And same thing goes with systems of 3 equations, 3 unknowns. There's going to be 2 just straight given to you, and then 1 where you actually have to come up with a system and solve it yourself from an application problem. And then there's going to be on the section 3, there's going to be 2 nonlinear systems of equations given to you, and you have to solve those for x and y. And then the third one is another application you have to come up with your own. So that's going to be the normal things. And then the partial fractions, there's going to be one of each type. And so basically, as long as you know how to do each of the different types, you'll be fine there. And on that one, remember, I'm not going to make it so there's going to be lots of square roots of square roots of a square root. So you don't have to, if you practice on those and you start getting some really weird answers, that's probably not one that I'll be giving you in the actual homework, because I think it's up to, if I don't remember off the top of my head, but I think up to 30 or something on that section is sort of good. And then after that, it gets really bad. It gets some really hairy numbers, and I don't really want to, it'll take you hours just to get one problem done with that. So I'm not worried about if you can do it. I just want to know if you can do a normal, simple partial fraction kind of decomposition. So same with the nonlinear systems of equations. Those are hard too, and I think around 32 or something on those, they get kind of squirrely as well. So kind of be watching for those. If you get a problem that just is not working out well, I would say that's probably not one example that I'm going to be giving. So.
And one more thing. So are we gonna have like Zoom open or whatever at the same time as we're taking it so that you can like watch us, or how?
Yeah, I'll send out a link, and well, actually, it's just going to be our class link. It's just going to be that day of the test. It's just going to be our Zoom class, and you just have to turn on your video and have your audio on so I can listen to you and also kind of watch you to make sure you're, doing your own work and not having somebody else sit there do your work for you.
Cool.
Yeah. So then, if you guys are, you and Ben, you're in the same house, so you're going to be using the same Wi-Fi.
Yes. Is that bad?
Well, no, it's not bad, but it might stress your Wi-Fi, so that might be the only issue, is what I'm thinking. So,
Man, everything is already stretched because everyone's at home. So, like, I guess, like, we're not getting the same speeds we're supposed to even be getting because everybody's at home using Wi-Fi everywhere in the neighborhood. So,
yeah, it's the same here. Then I've got kids at home trying to watch YouTube or do other stuff, and it's like or they're actually doing homework too some days. So, yeah, it's kind of hard. So we'll
Well,
get by with what we can get by with.
yep.
I'm in the dorms and it's really bad here. Like you cut out all the time. So I missed like half the lecture today.
Oh, nice.
Yeah.
I would think the dorms would be like super fast as far as because you've got a good connection. You've got a T1 connection over at the college, and it's supposed to be really fast. So it must be all the people must be really pulling it down there over there. So
I used to live in the apartments by the dorms, and I like just moved out like a week ago. But like once this whole COVID-19 thing started happening, that Wi-Fi like went out. Like as soon as I got back from my vacation, the Wi-Fi didn't work at all anymore in those apartments. So I imagine it's just as bad at the dorms.
probably, yeah.
Like trying to do this yesterday, I had to reload the thing at least because it just kept kicking me out.
Yeah, I got kicked out once yesterday too in the middle. If I'm sure you probably noticed that. I was sitting there talking along, all of a sudden it goes, doop, disappeared. I'm like, oh, great. So luckily it kept recording, and I just came back and started talking again. So, and that might be a thing, if it gets too bad when we're doing these live classes, we might just have to go to, I record a video on just me only, and then you just watch them whenever you have the bandwidth to actually watch them too. So, if it starts getting bad, a lot of faculty have gone to that because, their students don't have Wi-Fi where they are. They're trying to steal Wi-Fi from a hotel or something out in the parking lot, and it just doesn't work very well. And so if that's the case for live sections, maybe we'll just switch to the asynchronous. I record the videos, you just watch them when you're ready to do the homework or right before you do your homework, and do it that way. And then we don't actually have this synchronous stuff unless you have questions, and then we can have a like an office hour and ask questions at that point. All right, so that's all I have for today then. So I will see you tomorrow, and we'll start 3.2.
Bye.
Bye.